ഹലോ ഗുഡ് ഈവനിങ്. ഈ വീഡിയോയിൽ നമ്മുടെ ടെക്സ്റ്റ് ബുക്കിലെ പേജ് നമ്പർ 117 പ്രോബ്ലം 8 ചെയ്യുകയാണ്. ഇതാണ് പ്രോബ്ലം. If Z is an n-1 dimensional subspace of an n-dimensional vector space capital X, show that Z is the null space of a suitable linear functional f on X, which is uniquely determined to within a scalar multiple. അതായത് we want to show that Z is the null space of some linear functional f. So we have to define a linear functional f. So we are going to solve this in this way. We will define a function f. We will show that that is a linear functional. Then we will show that Z is the null space of f. So the first part is then will be proved. And what is the second part? Which is uniquely determined to within a scalar multiple. എന്ന് പറഞ്ഞാൽ എന്താ അർത്ഥം? If Z is the null space of some other linear functional g, then this g is a scalar multiple of f. So first we want to show two things. Z is the null space of a suitable linear functional, and if Z is the null space of some other linear functional g, then g is equal to a scalar multiple of f. See, we will do this one by one. It is given that capital N X is an n-dimensional vector space. So let B is equal to x1, x2, etc. xn be a basis for capital X. And is given that Z is an n-1 dimensional subspace of capital X. Z is of dimension n-1. So we can take n-1 vectors from the basis of capital X and form Z. Z is any n-1 dimensional subspace of capital X. Any n-1 dimensional subspace of this capital X can be formed by taking any n-1 vectors from the basis capital B of X. So let the basis of Z be, say, x2, x3, etc. xn. Now since this B is a basis for capital X, capital X le ഏത് element x എടുത്താലും that x can be uniquely represented as alpha 1 x1 plus alpha 2 x2 plus etc. plus alpha n xn. Now we define a function. Define a function f from x to the concerned field capital F, defined by f of x is equal to capital X le ഏത് x എടുത്താലും അതിനെ ഇങ്ങനെ എഴുതാൻ പറ്റും. Then the image of x under f is alpha 1. This is the definition of f. That is a coefficient of the vector x1 in the unique representation of x. So this is a function, and this is a functional because it is defined to whose range lies in the field. So this is a functional. Clearly f is a functional. Now we will show that f is linear also. For that, suppose we take x and y belongs to capital X. X has a unique representation alpha 1 x1 plus alpha 2 x2 plus etc. plus alpha n xn. Y has a unique representation beta 1 x1 plus beta 2 x2 plus etc. plus beta n xn. Then alpha x plus beta y. Alpha x plus beta y is also an element of capital X, and that has the unique representation alpha 1 plus beta 1 x1 plus etc. plus alpha n plus beta n xn. See, with the definition, with this as x, we have by definition f of x is the coefficient of x1, that is alpha 1. F of y, that is a coefficient of x1, that is beta 1. Therefore f of alpha x plus beta y, that is also the coefficient of x1, that is alpha 1 plus beta 1, that is alpha f of x plus beta f of y. Therefore f is linear. Thus we have defined a linear functional. F is a, നമ്മളിപ്പോൾ define ചെയ്ത ഈ f is a linear functional. Now we can show that the null space of f is Z. So what to show next? So we proved this. This is the first part. We proved the first part. We constructed a construction of a linear functional that we have constructed. Now we will show that. So the second part is to show that Z is the null space of f. See, we want to show that two sets are equal. This we will do one by one. We will first show that Z is a subset of null space of f, and on the other way. So you take an Z belongs to Z. That small z belongs to capital Z. And we know that the basis of Z is x2, x3, etc. xn. Therefore, this Z belongs to capital Z has a unique representation, say gamma 2 x2 plus gamma 3 x3 plus etc. plus gamma n xn. Therefore, f of Z is equal to, by definition, f of Z is the coefficient of x1, and the coefficient of x1 here is 0. So this is 0. So if you take any Z belongs to Z, f of Z equal to 0. Therefore, Z belongs to the null space of f. Therefore, Z is a subset of null space of f. And on the other way, we take an element from null space of f. So let Z belongs to null space of f. Therefore, f of Z equal to 0. See, why this f of Z equal to 0? Z in a, see, Z is in fact an element of capital X. അപ്പോൾ Z നെ x ന്റെ ബേസിസിലെ എലമെന്റ്സ് ആയ x1, x2, x3, etc. xn ന്റെ ലീനിയർ കോമ്പിനേഷൻ ആയിട്ട് എഴുതിയ സമയത്ത് x1 ന്റെ കോഎഫിഷ്യന്റ്, Z നെ അങ്ങനെ ലീനിയർ കോമ്പിനേഷൻ ആയിട്ട് എഴുതിയ സമയത്ത് x1 ന്റെ കോഎഫിഷ്യന്റ് 0 ആയിരുന്നു. എന്ന് പറഞ്ഞാൽ എന്താ അർത്ഥം? Z ന്റെ റെപ്രസെന്റേഷനിൽ x1 ഇല്ല. x1 ന്റെ കോഎഫിഷ്യന്റ് 0 മീൻസ് x1 ടൈം ഈസ് ആബ്സെന്റ്. അപ്പൊ പിന്നെ Z ന്റെ റെപ്രസെന്റേഷനിൽ therefore Z, f Z equal to 0 means coefficient of, therefore by definition coefficient of x1 equal to 0 in the unique representation of Z as a linear combination of x1, x2, etc. xn. If x1 illengi pinne Z pinne arude linear combination aayirikkum. Therefore, Z is a linear combination of x2, x3, etc. xn. ഇങ്ങനെ x2, x3, etc. xn ന്റെ ലീനിയർ കോമ്പിനേഷൻ ആയിട്ട് വരുന്നതെല്ലാം ക്യാപിറ്റൽ Z ലെ എലമെന്റ്സ് ആയിരിക്കും, because the basis for Z is x2, x3, etc. xn. Therefore, Z belongs to capital Z. നമ്മൾ null spaceൽ നിന്ന് ഒരു എലമെന്റ് എടുത്തു, we proved that that belongs to Z. Therefore, null space of f is a subset of Z, call it as 2. So from 1 and 2, therefore from 1 and 2, therefore from 1 and 2, Z is equal to the null space of f. So our second part is also proved. We proved that Z is the null space of a certain linear function. Now what it remains to show? Third part, uniqueness of f. Up to a scalar multiple. അതായത് വേറെ ഏതെങ്കിലും ഒരു ലീനിയർ ഫംഗ്ഷണലിന്റെ null space ആണ് Z എങ്കിൽ we will show that that linear functional is a scalar multiple of f. That is what is meant by uniqueness of f up to a scalar multiple. F unique ആണ് up to a scalar multiple means f ന്റെ മൾട്ടിപ്പിൾസിനും ഈ ഒരു പ്രോപ്പർട്ടി ഉണ്ട്, അതല്ലാതെ വേറെ ഒരു ഫംഗ്ഷനും ഇല്ല. Suppose G be another linear functional such that Z is the null space of G. To show that G is equal to a scalar multiple of F. Okay. So for that, we want to show that Gx is equal to C of Fx for all x belongs to capital X. അങ്ങനെയാണ് രണ്ട് ഫംഗ്ഷൻസ് ഐഡന്റിക്കൽ ആകുക അല്ലെങ്കിൽ ഈക്വൽ ആകുക. So you take an x belongs to capital X. So let x belongs to capital X. Therefore, x has a unique representation alpha 1 x1 plus alpha 2 x2 plus etc. plus alpha n xn. And it is given that G is linear. G is linear. Therefore, Gx is equal to, see, apply the linearity of G. Gx is equal to alpha 1 gx1 plus alpha 2 gx2 plus etc. plus alpha n gxn. Now, it is further given that G, Z is the null space of G. അപ്പോൾ ഇസഡിലുള്ള എല്ലാ എലമെന്റ്സിനെയും G 0യിലേക്ക് മാപ്പ് ചെയ്യും. ഇസഡിന്റെ ബേസിസിലെ എലമെന്റ്സ് ആണ് x2, x3, etc. xn. So all these terms are zeros. So what remains is alpha 1 gx1. And what is G? G is a linear functional. So it is a function from x to f. Therefore, this gx1 is a scalar. In capital F. And we call that as C. So this is equal to C alpha 1, where C is equal to gx1 belongs to capital F. Now this is equal to C, and what is alpha 1? By definition of F of x എന്ന് പറയുന്നത് x1 ന്റെ കോഎഫിഷ്യന്റ് ആയിരുന്നു. So this alpha 1 is f of x. Therefore, Gx is equal to Cf of x. This is true for all x belongs to x. Therefore, G is equal to Cf. And hence the solution. We showed that we proved the existence of a certain linear functional. We showed that Z is the null space of that linear functional. Then we showed that if G is any other linear functional such that Z is the null space of G, that G is a scalar multiple of F. And that is the solution. Okay, thank you.